Memory semiconductors are used to store information. Memory semiconductors can be largely divided into RAM, random access memory, and ROM, read-only memory. RAM is volatile memory, which means that the stored data disappears when the power is turned off. RAM is a temporary storage space for computers, directly connected to the CPU, allowing for fast reading and writing of data. ROM is non-volatile memory, which means that the stored data is maintained even when the power is turned off. ROM is a space for storing basic operating programs or firmware of a computer, and only allows for reading of data or has limited writing. Memory semiconductors come in various types depending on the amount and speed of information. For example, RAM has generations such as DDR, DDR2, DDR3, DDR4, etc., each providing improved performance with higher bandwidth and lower power consumption. Also, RAM has interfaces such as UDIMM used in general PCs or servers, SoDIMM made smaller for laptops, GDDR specialized for games or graphic work, LPDDR used in smartphones or tablets, etc. ROM is used in forms such as CD-ROM, DVD-ROM, BD-ROM optical discs, flash memory, etc. Memory semiconductors are components that greatly influence the performance and efficiency of electronic devices. Therefore, memory semiconductors play a key role in the advancement of modern IT technologies such as cloud computing, AI, IoT, etc. Memory semiconductors are semiconductors used to store information. Semiconductors are largely divided into memory semiconductors and non-memory semiconductors, where memory semiconductors are used to store information, while non-memory semiconductors are used for information processing such as operations or logic. Memory semiconductors are further divided into RAM, random access memory, and ROM, read-only memory. RAM can not only record information but also read or change recorded information, while ROM can only read recorded information and cannot record or change it. RAM is the main memory of a computer, storing information necessary for executing programs and data. RAM has the characteristic of disappearing when the power is turned off. RAM is largely divided into DRAM, dynamic random access memory, and SRAM, static random access memory. DRAM stores information in capacitors, has a large storage capacity and is cheap, but the stored information disappears when the power supply is cut off. SRAM stores information in transistors, is faster and consumes less power than DRAM, but has a small storage capacity and is expensive. ROM is used to permanently store programs or data. ROM has the characteristic of not disappearing even when the power is turned off. ROM is largely divided into PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, EEPROM, electrically erasable programmable read-only memory. PROM can only be programmed once, has a large storage capacity and is cheap, but cannot be programmed. EEPROM can be programmed using light, is easier to program than PROM, but needs to be careful of UV, ultraviolet, exposure. EEPROM can be programmed using power, is easier to program than EEPROM, but the number of programming times is limited. Memory semiconductors are essential core components used in various electronic products such as computers, smartphones, communication equipment, home appliances, etc. The technological advancement of memory semiconductors greatly contributes to improving the performance and functions of electronic products. Recently, with the advancement of new technologies such as artificial intelligence, AI, Internet of Things, IoT, cloud computing, etc., the demand for memory semiconductors is rapidly increasing. As a result, the competition for technological development of memory semiconductors is becoming more intense. The main technological development trends of memory semiconductors are as follows. High capacity. In response to the explosion of data, technology development to expand the capacity of memory semiconductors is actively underway. High speed. In response to the demands of high-performance electronic products such as artificial intelligence, 5G, etc., technology development to improve the speed of memory semiconductors is being carried out. Low power. As power consumption becomes an important factor, technology development to improve the power efficiency of memory semiconductors is underway. The advancement of memory semiconductor technology is expected to greatly contribute to improving the performance and functions of electronic products and promoting the development of new technologies.